starting chapter 12 today. It deals with three-dimensional figures. A lot of this information is on the EOI, so you need to pay close attention. This chapter overall, I don't think is all that hard. It's a lot of formulas. So if you're pretty good at plugging stuff into a formula, you ought to be in good shape. Some of us did really well on the test, some of us not so good. You need to probably figure out what you're doing wrong, because you're going to use this stuff in this chapter, okay? Today's lesson is a lot of vocabulary and just a lot of little different weird things about solids. All right, so we're going to talk first of all about what polyhedron are. And polyhedron is closed three-dimensional figures made up of flat polygonal regions. Okay, like a Kleenex box is a polyhedron. Okay, each one of the sides is a polygon. All right. And each one of those flat polygons is called a face. There's lots of, here's another, these are examples of polyhedron. Okay, the flat regions are called faces. Where those flat regions intersect is called an edge. So they come here and they intersect here at an edge. And then where the edges intersect is called a vertex. So we've got faces, edges, and vertices that make up our polyhedron. We have a couple of different types of polyhedron. One of them is a prism. And a prism is a polyhedron with two congruent faces that are polygons contained in parallel planes called faces. So like here is a prism, okay? And you've got several faces here. You've got three what's called lateral faces, and then you've got these other two faces that are also called bases. Okay, your bases, they are congruent and they're parallel to each other. Okay, the other faces are called lateral faces because they make up the side. Lateral means side. So in this particular one I'm holding in my hand, you've got these triangular bases, okay, which are also called faces, and then you have these rectangular lateral faces. All right, all of them are faces, but these two are special because they're called bases. I'll come back to that in just a second. Regular prisms are those in which the bases are regular polygons. So this right here, this triangular prism here is regular because the bases are equilateral triangles. Okay. A cube is a prism in which all the faces are squares. Here's a cube. Okay, and this cube has another name that we'll talk about in just a second. But each one of the faces are congruent regular polygons. Okay, they're all a square. All right. Now, when you name a prism, you name it according to its base. Okay. This one right here, even though it's laying on a rectangle, that's not the base. Okay. The base are these congruent polygons that are parallel to each other. So this is considered a triangular prism. So the bases are triangles, the lateral faces are rectangles. It just happens to be tipped over on its lateral face. A rectangular prism, okay, the base is a rectangle, like a Kleenex box, all right? Now, this could have different bases. It just depends on how you want to look at it. You could have this 15 by 8 inch base, okay, which would be these two. And then the other faces would be your lateral faces. You could also have your 10 by 8. Those could be considered your bases. It's just tipped over, okay? Or you could have these as your bases. Okay. So your rectangular prism is the only one where your base can vary depending upon how you want to look at it. Okay. The other ones are pretty set forward because the bases have to be congruent and parallel to each other, which is what happens in a rectangular one. So like in this triangular prism, you only have one option for your base, which would be the triangle. Even though if it's laid over on its side, these are still bases. Okay, because it's a triangular prism. Here's another example of a pentagonal prism. Okay, it's also laying on its lateral face, but the bases are regular pentagons. So this is actually a regular prism because the base is a regular pentagon. Okay? So that's a pentagonal prism. So you name the shape according to what its base is. Now another type of polyhedron is the pyramid. And the pyramid is another type of polyhedron that has all faces except one that intersect at a vertex. Okay, so here's an example of one here. This one, and you name it according to its base also. What I have in my hand is a triangular pyramid. And then the faces are triangles. They're actually, looks like isosceles triangles. And all of those lateral faces intersect at a point at the top called the vertex. Here's examples of two of them. This one's a square pyramid. It doesn't have a mark, but this is a square pyramid. This is a pentagonal pyramid. And then the third type of polyhedron we're going to talk about is the platonic solids. And these are regular polyhedron, which means each face is shaped like congruent regular polygons. And you need to know these. You've been familiar with these. Okay? There's 5 of them. And over here in the room and up here over my desk, we did these platonic solid mobiles. Alright? These are mobiles. And your first one is the tetrahedron. Okay? All of these end in hedron, and then the first part of the word denotes how many faces there are. So this one used tetra, that means 4. So tetrahedron, it's got 4 faces, and they're all equilateral triangles. They're congruent to each other. So that's called a tetrahedron. Your hexahedron, also called the cube, has 6 faces. Hexa means 6. 6 faces, and they're all squares, all congruent squares. The third one is the octahedron, octa meaning 8. Okay, it has 8 faces, and all of those are equilateral triangles. And then we have dodecahedron. Remember, deca is 10. Dodeca has 2 more letters, so it is 12 faces that are all pentagons and regular pentagons. And then your last one is an icosahedron, and that's 20 faces, and those are all equilateral triangles. So you need to know those: tetrahedron, hexahedron, octahedron, dodecahedron, icosahedron. A question might be, which of the following is not a platonic solid? Okay, so it might give you tetrahedron, hexahedron, decagon, and dodecahedron. And you have to tell me which one is not a platonic solid. Okay, I might say, how many faces are there in an octahedron? Okay, I might say, what is the shape of the face in a dodecahedron? Okay, so you need to be familiar with those kinds of things. All right. Okay, then we have our non-polyhedron, and that is our cylinder, our cone, and our sphere. The cylinder is something like a Pringles can, a green bean can, something like that. A solid whose bases are formed by congruent circles and parallel planes. So here's a cylinder. You've got these 2 bases. Okay, they're not a face because they're not a polygon. Okay, these are 2 bases. They're congruent and parallel to each other, and they're circles. And that's what makes up our cylinder. The next one is a cone. You know, the cone has 1 circular base, and then it's got this rounded part here is the lateral area, the lateral surface area, and then this is the vertex, and it's in a different plane than the base. And then we have the sphere, and this is what we're going to talk about when you guys are on for that field trip that you're going to. We're going to talk about the surface area and volume of the sphere. And it's the set of all points that are a given distance from the given point called the center. Okay, so inside here is a center. Now this right here is a hemisphere. Okay, it's a hemisphere. And the center of this hemisphere is also the same as the center of the sphere. This hemisphere basically cuts the sphere in half. It contains the same center, and they have the same radius. So that from the center of the hemisphere, the distance to the outside of the sphere is always the same. It's called the radius, just like in a circle. Okay. If you cut it in half, like I said, you get a hemisphere, and then this flat portion is called the great circle. Okay, it's called the great circle. And we're going to have any questions about that today, but that will be on what we talk about on Wednesday. Okay, so those are your non-polyhedron. All right, so we're going to answer a few questions. These are really pretty easy. It says identify each solid, state the number of bases, faces, edges, and vertices. So we look at this first one, and this is regular. Okay, and so how would I name this? A square pyramid. many of those are lateral faces? There's 4 lateral, 5 faces altogether. So, and how many bases are there? 1. How many vertices? 1, 2, 3, 4, 5. Okay, good. And edges? 4. And you can have lateral edges and base edges. Okay? The lateral edges is where the lateral faces intersect. The base edges is where the lateral face intersects the base. So there's 4 lateral and 4 base. So that makes a total of 8. What is the shape of the base? Square. It's the square pyramid, right? And what is the shape of each lateral face? Triangle. Now, they're probably, if this is a right pyramid, we'll talk more about that tomorrow, a right pyramid, they're probably isosceles triangles. Okay? All right. What about this one? How will we name this one? Triangular prism. Triangular prism. How many faces does it have? 1, 2, 3, 4, 5. Okay. How about lateral faces? 3. Bases? 2. How about vertices? 6, right? And edges? How many lateral edges are there? There's 9 altogether. 3 of these are lateral edges, and then you've got 3 bases on one, 3 lateral edges on one base, 3 lateral edges on another. So that makes a total of 9 edges. What is the shape of the base? What's the shape of the base? Triangle. It's laying on its lateral face, but it is a triangle. The base is a triangle. What's the shape of the lateral face? Rectangle. We don't know that it's square necessarily. Okay, what's this solid? Cone. What's the shape of the base? Or name the base. How would you name that base? What's the shape of it? Circle. And how do you name a circle? With the center. So it would be circle S, right? Okay, name the vertex. R. Okay. All right, any questions on how we did any of those before we go on to the next thing? Questions? Okay. All right, now, what these are nets. I don't know if you guys worked with these maybe pre-algebra, but basically what happens is you take a solid and you cut it apart and lay it out flat. Okay, and so what they want you to do is put it back together in your mind and tell what shape it is. Okay? All right, so if you look at this first one, it's got a square base and it's got these 4 triangles. If you flip all 4 of those triangles up, they're going to intersect at a point. So what does it make this? This makes a square pyramid. Okay, now this one, it looks like it has 3 lateral faces. So if you fold those up and then flip those triangles down, what would this be? Triangular prism. Okay, what about this guy? What shape is it? The cube or the square prism? Or what else do we call this? If they're all squares, a hexahedron. Okay, now here's a good question. I've seen questions like this. I know they always have them on the review for the EOI. Which face would be parallel to the yellow face? So again, you got to put it together in your mind, and which one's going to be parallel to it? The G, the green. Okay, another thing they might say is which face is not adjacent to. Not adjacent means not next to, which is the same as being parallel to it. So it would still be green, right? It's just a different way to ask the question. Okay? All right, here's another one. This looks kind of backwards. What shapes would appear in drawing a net for a hexagonal pyramid? What? Not a square, hexagonal pyramid. So what kind of base is it going to be? It's going to be a hexagon. Okay, and pyramid, what are the lateral faces going to be? Triangles, right? So then if you flip those up, you would get a hexagon pyramid, right? So we would need one hexagon and 6 triangles. And if you have to draw it out, that's okay, all right? You need to make sure that you're thinking, pyramid as opposed to prism and whatnot. All right, any questions on that before we go to the next page? Okay, now, for anybody in here in pre-engineering, okay, some of you are in pre-engineering. You guys probably do this stuff all the time. My brain doesn't think very good like this. I usually have little blocks for us to work with, but we don't have enough time to mess with that too much. Basically what this is, it's called an orthographic drawing. And what it does is it shows the top, the left, the front, and the right view of a three-dimensional building, okay? And so this is the orthographic view, and then if you wanted to draw the actual three-dimensional building, that's called the isometric view, okay? And I'm not sure if they do this in pre-engineering or not, but if you notice, some of these are kind of darkened in a little bit. Our book does this, like I said, I'm not sure what they do there. But the darkened part of it tells you that there's a change in the elevation, okay? And so, if you were to look at the top view, that means if you were to look down at the top of it, you're going to see 4 blocks. If there was no darkened lines, those 4 blocks would all be smooth. They'd be the same elevation. But see how they've got these darkened parts? That means that these 2 are at a different elevation, and then these 2 are together, but at a different elevation than the other 2. Okay? So here, if you look, you've got the 4 blocks. And see, these 2 are the top, but they're at different elevations, and then these 2 are together, but they're below both of those. Okay? So this tells me that that's what this looks like. Okay? All right? Then this right here is the front, this is the right, of course this is the top, and then the left is on the other side. If I were to rotate this building, okay, and look at the left side, see how it's got 3 blocks and then 1 that juts out. If I rotated this, it would have 3 blocks that were smooth and the 1 that juts out, but they would all be smooth together. There'd be no change in elevation. Then if I looked at the front, okay, these are all front. I've got the 1, 2, 3, and those are all flush with each other. And then I have these 2, okay, that are set away from the others. That's why we've got the darkened line. And then we have the right view. In the right view, we've got 3 going down and then the 1 jutting out. They're all smooth except the 1 at the top is set back from the others. So that's why they've got the darkened line. Okay? And so you should be able to look at these orthographic drawings and come up with this isometric picture, okay? And so that's kind of some things that they're going to ask you on the test. Now, it'll probably be a little more simple than that. Like I might give you something like this. Here's the isometric drawing, and I want you to create the orthographic drawing, okay? So here's the front and the right. I want to know what the front will look like. What would the front look like? Here's the front, right here. Okay, there's the front. So how many blocks are there? What shape is it? This might be more helpful to look at it like this. This right here, if I look at the front, what shape is that? It's an upside down T, right? Are they all flush? Yes. So what I would do is I would make myself an upside down T. I've got a block here and here, here, and here. So that's what the front view is. Okay? Now I want to look at the right view. Okay? And so if I were to rotate it, this right here, there is my right view. Okay? So how many blocks is that? 3 blocks going straight down. Okay? Are any of them at a different elevation? This bottom one. So I would need to make this line here darker to show me that those are at a different elevation. Then blocks, right? Straight across. Okay? Are they all at the same elevation? No, they're all different, aren't they? Okay? So I have to put a darkened line here and a darkened line there. Okay? So that's going from the isometric to the orthographic. You should be able to go from the orthographic to the isometric, which to me is hard. Usually, if they give me these, I've got to get little blocks, put it together, okay, and then rotate it and draw the picture. And we're not going to take time to do that, and we have done that in the past, so we don't have time to do that right now. On your test, it might look something like this, or they give you the top, the front, and the side, and they might give you several figures, and you have to pick which one matches this orthographic drawing. Does that make sense? Okay, that's probably what it's going to be like. When we do the EOI review next week and the following week, there is a couple of questions like that, and you'll see what they're talking about. All right, so the last thing we want to talk about is the cross section. And a cross section is the intersection of a solid and a plane. The shape of the cross section formed by the intersection of a plane and the three-dimensional figure depends on the angle of the plane. So basically, here's some examples of some cross sections. Okay. But if you take a cone and you cut it right here, like you just go straight across and cut the top off, the cross section is a circle. Okay? You're going to cut it right here, open it up, you get two circles, right? If you went and cut it vertically right down the center and opened it up, okay, it would actually be a triangle. That would be the cross section. If you did an angled cut, okay, see how you got this pink one or coral color, whatever color that is? This looks like an oval. It's also called an ellipse. And you guys will learn more about that when you take Algebra 2. Okay? But this right here, the technical name here is going to be ellipse. It's kind of like a stretched out circle. So, looking at these, we cut that cylinder right through the middle there. What are we going to get? It's a circle. Okay? What about if we make an angled cut like that? What's that? Ellipse. Okay, if we go straight down, and it's not a square, probably more of a rectangle.